You probably have heard that it's not a good idea to look at an eclipse. Let's take a look at why we shouldn't do so. Let's look at the structure of the human eye. So this clear part is called the cornea, and this white part called the sclera. Let me just take it off so we can see the inner portion of the eye. And this right here, inside the eye, is called the lens. Now what happens is the cornea and the lens helps to focus light directly on this reddish portion that is called the retina. The retina has the cells in the nervous tissue that will take all this light information and send it through the optical nerve to your brain. That allows you to see. So these two structures help to focus light directly on the retina. Now another structure of the human eye is this structure right here, and that's the iris. The iris is the colored portion of your eye. The iris is made up of muscles, and they control the opening that you see right there. The opening you have in your eye, that dark part, is called the pupil. So by allowing the iris to expand, not expand, but contract and relax, they will actually allow the pupil to get bigger or smaller and really control the amount of light that gets into your eye. The other function of the iris is also to protect the retina in your eye from receiving too much light. So in other words, when you go from, let's say, a dark area to a light area, you notice that, you squint, and also your iris will change the size of the pupil so that it's smaller, so there's less light that enters your retina. That is called an inversion reflex, and it's there to protect your eye from getting too much light, and in a sense, protecting your retina from being damaged by light. So what does this have to do with an eclipse? Don't light levels usually decrease during an eclipse? So should your eyes be okay? Well, the other thing I didn't mention is that the sun not only releases visible light, but other types of light, such as infrared light, which is heat, and also UV light. So let's look what happens during an eclipse. So during an eclipse, there may be less visible light. So when a person looks at it, the pupils will get a little bit bigger to allow more light going in. And also, because there's a bit less light, there's less of an inversion reflex, and they might force themselves to look at an eclipse even longer. But don't forget, there's other types of light that will enter the eyes, such as infrared light. And this infrared light, with the help of the cornea and the lens, will be focused on the back of the retina, a bit like, when you take a magnifying glass in the sun and you burn stuff. Well, it will burn the retina in the back of the eye. And the worst part of that, there's no nerve endings in the retina, so the person doesn't even know they're doing damage to their retina. So what happens when a person has retinal damage? Well, usually the symptoms appear the next day, usually a loss of vision, blurry vision, distorted vision. Maybe they'll have blind spots in one or two eyes. It may even have a decreased sensitivity to light, or may not be able to see certain types of colors. Unfortunately, there's not much that can be done to treat that. Most people will recover after 3 to 6 months, but some people might have permanent vision loss. So how can we view an eclipse safely? Well, we could use special glasses with solar filters that will block out most of the sunlight. And these solar filters have a specific standard on them that's written on them, an ISO 12312-2 standard. So it's written on the glasses. That indicates that it's safe to use these solar filters to look at an eclipse. Just make sure that the solar filters haven't been damaged by folding or a scratch. Another way to look at an eclipse is through indirect viewing using a pinhole projector. So you can use these two methods to be able to view a solar eclipse safely without damaging your eyes.